So then you can classify epithelial in multiple ways. So one major way you can classify and categorize epithelia are based on the shape of the cells. So they're squamous, cuboidal, and columnar. There are exceptions, but I'll cover those exceptions pretty soon. So what we have with this is that squamous, notice that they're pretty flat, whereas cuboidal, well, when you have a cube, you have multiple, or it's a cube, with the cube, what happens with the cube? You have all the sides are the same, so it's as wide as it is tall as it is long. And the columnar, they're like columns. They're tall and not too wide compared to their height. So this is the way I consider it. When I'm looking at tissue, this is how I classify it as squamous, cuboidal, or columnar. I look at the width, and the width is going to go along this basement membrane versus the height. So the height, what I mean by that is the distance between the apex and the apical and basal surface. So going from that outer surface towards the basement membrane. So with squamous, or squamous, sometimes people, squamous, squamous, tomato, tomato, what you see is that they're broader and flat, but they don't have much height compared to off the membrane. So they're pretty like, and I think the Latin term for squamous or squamous or whatever, is that it comes from the Latin, I believe, for scales. So scales are flat and broad, so same with squamous cells. Now cuboidal, well, just like that, the geometry definition of a cube, the width is about the same as the height. So again, even I use this approximate because, okay, it doesn't have to be exactly the same width, height, and length, but it's just saying you like none of the dimensions are massively out of proportion compared to the others. And columnar, well, again, just like the column in a building, what you see is that they're very tall, but not too much width. So again, if you have it about the same, it's cuboidal, but if it's flatter, it's squamous. If it's taller, it's columnar. Now, what we see here, so this is the Martini version, and people be like, wait, isn't this kind of the same as the same width and height? And I'm like, it's kind of funny. It's like instead of looking at the cells like here, you're actually kind of turning it so you're actually looking at it from above. So this is just showing that they're broad and flat, and I should check what type of stain. It's probably H&E. So we have all the nuclei here, and then we have other surrounding membranes of the cells. Now cuboidal, this is showing you a cross section, so it's kind of like taking a layer of cells and just seeing it this way. So what we see here is like, okay, it's not going to be perfectly equal width and height, but compared to flat cells, they're pretty much about even in terms of like their height off the membrane, from going from apex to base, and also roughly equal in their width as well. And columnar, now this is pretty obvious right here. So notice that from this basement membrane over here, we have a very tall height going from apex to base, and individually these have a very, like compared to this height over here, we have a pretty short width compared to the height. So that's the basic differences between squamous, cuboidal, and columnar. Now the thing is that structure, so this is a term you often hear in anatomy and physiology, and is that structure determines function. So basically the shapes aren't just random. The shape actually affects how the cells act and the role of the cells in the body. So the thing is that I like to think of it this way. So squamous cells are kind of like those thin paper, like a very thin curtain, or if you've seen those Japanese shoji doors, like what they have are rice paper doors. So not very strong, but very flat. But the cool thing is that columnar cell, so I also think of columnar cells, they're very thick. So they're kind of like a brick wall. They have this thickness that's harder to poke through. It's like, it's easy to like burst through a paper screen door, but kind of bursting through a brick wall, maybe if you're the Hulk, but again, it's like this is much more durable on the columnar side than a very thin layer over here. So then so this is like a thing of this. Squamous is kind of like thin and airy, and columnar is dense and closely packed like all these bricks over here. Now squamous cells are very fragile and columnar are durable because a squamous layer of epithelial cells very thin compared to this very, 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 very thick columnar layer. Now the cool thing about squamous, like we might be like, well, if it's delicate, why even have it in the first place? The cool thing is that these squamous, it's like having a curtain door versus or a rice paper door. It actually is more breathable, and more permeable. And by permeable, I mean that things can diffuse across a thin layer more easily than if they had to go through a very, very thick layer. So air would be more likely to go through a squamous layer of cells than a columnar layer of cells. So less permeable. And cuboidal is kind of in between, so you have a little trade-off. It provides a little more durability than the squamous, but it has a little less diffusion as well. So it's not just about physical properties and also like diffusion, it's also about other functions as well. So think about it this way, squamous is kind of like a flat but not very tall structure. Cuboidal is about as wide as it is tall. So think about this like those enzymes in the cell. They're like little workhorses that help to process all these chemicals. Now if you're starting a company, well, where can you have your headquarters and hire more workers? In a very flat but not very tall building, or something that has the same footprint but multiple stories? Well, you can fit more workers and hire more people in a taller building, right? And same with a columnar. So a columnar is going to be even taller, and say these buildings all have the same footprint, you're going to be able to stack so many people in this company over there. Now, in terms of your cells, which would have more enzymes? A squamous cell, a cuboidal cell, or a columnar cell? So a columnar cell, this is why even though columnar cells are not just durable, they're also able to pack more organelles, more enzymes, more chemicals, more cytoplasm. So this is another feature of columnar cells. They're able to actually have more inside one cell compared to a squamous cell, which is very flat, but there's not much room for anything else. Okay, so here we have so think about, this is why there are different shapes. There are different trade-offs depending on like the bulk of and volume of the cell, and also the thickness of that epithelium as well. Yeah, see? Small, medium, large. Yeah, that's another way you can think of it as well. So like flat, medium, and like tall, or like small, medium, large. But the thing is that why would we want a delicate squamous cell? Well, if you have a molecule like a gas molecule like carbon dioxide or oxygen, it's going to have an easier time diffusing across a smaller distance than it would have to travel all across this columnar cell. Same with water and other solids as well. Like if you have something like a sugar molecule or amino acid, it's easier to cross this than it is to cross here, diffuse all the way across the cell, and then diffuse out the other end. But the thing is that with that, you also have more volume in the columnar cells because they have more, they're taller, they have more space, and you have more enzymes. So this is why a lot of cells and tissues that are responsible for producing things and secreting them towards some sort of surface on the inside or outside of your body, they tend to be columnar because they have a lot of working space for enzymes and organelles.